We're going to continue on with Unit 5, Chemical Reactions. So please label your notes Unit 5, Chemical Reactions. And today we're going to talk about balancing equations, so make sure to write that at the top of your notes as well. So a little bit review from first semester. Remember, physical changes are changes affecting the form of a chemical substance, but not its chemical composition. When we're talking about chemical reactions, of course, we're talking about chemical changes. And when we're talking about balancing chemical equations, we are talking about only chemical equations would have to have a chemical reaction that occurred. So just a reminder, signs of a chemical change, we can see 4 different things. One is there's a formation of gas, which can be seen by a fizzing or bubble. Another is the reaction will cause heat, light, or odor to be emitted. Another is a color change is produced, and the fourth is a solid is formed during the change. So you should have these in your notes from first semester. We are next going to talk about the laws of conservation of matter. We talked about this briefly first semester, and you talked about this a lot in physics with the law of conservation of mass and the law of conservation of energy, and it is very similar concept. But in chemistry, we talk about the law of conservation of matter. And in a chemical reaction, the quantity or amount of each atom does not change. So each side of the equation must have the same number of each kind of atom on it. And some of this video might be reviewed for middle school science, depending on how much chemistry you got into in 8th grade, most likely. But make sure you pause the video and write this law down. So one example that we see, law of conservation of matter, is if we had wood and we burnt it in oxygen, so oxygen around it, it would yield or produce ashes, carbon dioxide gas, and water vapor. So even though we have a fire and we don't really, it doesn't seem like the law of conservation of matter has been followed, the mass of the wood and oxygen actually does in fact equal the mass of the ashes, carbon dioxide, and water. So we did have the same number of each kind of atom on each side of the equation before the chemical reaction took place and after the chemical reaction took place. So, looking at these pictures and what we know about atoms and molecules, which image correctly shows the law of conservation of matter? Well, this one, let's see, we have 1 gray on the left, 2 whites. Okay, here we see we create a chemical compound. We have 1 gray, 2 whites. Here we don't have the same number of dark gray. This one we have not enough dark gray and too many white, or too many dark grays, not enough whites on the product side. And then here, this one does not follow the conservation of matter either. So this is the only picture that has the same number of dark gray and light and white on both sides, meaning the law of conservation of matter has been followed. So how do we write out a chemical change? Through a balanced chemical equation. So it's important that we understand what each of these parts are so that when we're talking through it, you know what each component stands for. So this whole thing, like I just said, is the chemical equation. Make sure to write this down, write this chemical equation out, and then label the different parts. You can use different colors if you have them handy, but you can also just use pencil. That 2 in both the reactant and the product side stand for the coefficients, or the number of molecules we have. The Mg, or the O, is the chemical symbol. The superscript right here, the subscript right here, 2, will represent how many atoms of, in this case, oxygen in the molecule there is. These are things that you already know, that we've already talked through. And then MgO would be the chemical formula, which you also have practice writing. That whole thing on the left side of the arrow, all of that is called the reactants. And then everything on the right side is called the products. And that arrow there stands for yields. So pause the video and label each of these parts. Next, draw these molecules. So pause the video, try drawing them, and we'll check these in class. So just label one of your shapes magnesium, 1 oxygen, and then draw what you think that would look like. We're going to continue on by talking about balancing chemical reactions. So we can first think about, what if we had to create a car? So we would need a car body, and typically we would need 4 wheels. But if you try and go to buy car wheels, typically they're sold in pairs. So in order to make a car, we need a car body and we need 4 wheels. So our product that we want to get to is 1 car body and 4 wheels. However, the wheels are only sold in 2 pairs of 2, and the car body is sold in 1. So currently I have 1 car body, 2 wheels on the side. Here I have 1 car body, 4 wheels. So what can I do to get, if I go to the car mechanic or the car shop, tire shop, and ask for, say I need 4 wheels, well, I'm going to order 2 packs of 2 wheels, or 2 sets of 2 wheels. So I'm going to put a 2 in front, saying that's how many groupings I want. So I want 2 groupings of 2 wheels. Then I can change down here. I'm showing all of my work. So now I actually have 4 wheels. I still have 4 wheels on this side. I still just have 1 car body because there's no coefficient, so it's balanced. I can also apply that same sort of example to balancing an actual chemical equation. So here, if we have carbon and Cl is chlorine, this is my chemical equation. Currently, I have 1 carbon because no coefficients and no subscripts. So 1 carbon, 2 chlorines. Here, I have no coefficients, but I have 1 carbon and 4 chlorines because that is the subscript. So what can I do to get 4 chlorines on this side because I want to have the same amount on each side? Well, I can never change the number of subscripts. I can only ever change the coefficients. So in order to get 4 on the reactant side, I could add a coefficient in front of the chlorine, and thus then I would have 4 chlorines on each side. I check my work again, 1 carbon on each side, 2 times 2, 4 chlorines on this side, 4 chlorines on this side. Next, if I'm talking about tricycles, so I get a new tricycle, I need to buy some wheels. However, these wheels are still only sold in pairs of 2. So I want as many complete tricycles as I can have. So of course a tricycle would have a trike body, 1 trike body, and 3 wheels. So currently I can buy trike bodies by themselves, and I can buy wheels only in pairs of 2. And then I want to produce a trike body with 3 wheels. So I have 1 trike body, 2 wheels on this side. This side I have 1 trike body and 3 wheels. So I go to the store, I'm like, well, in order to get at least 3 wheels, I'm going to have to get at least 2 sets of wheels. But that might not be the correct way to do it, so I'm thinking through it. Okay, well, if I get 3 sets of wheels, then I'll have 6 wheels total. Then I will be able to have 2 tricycles. So I add a 2 on that side, a 3 on this side. So then now I have 6 wheels that I've purchased, and I'll produce enough for 6 wheels. However, in order to have 2 complete tricycles, I'm going to need to also get 2 more trike bodies. So I put a 2 as my coefficient, change that to 2, check my work again, 2 trike bodies on both sides, 6 wheels, we're happy. We can do the same thing with a chemical reaction or chemical equation as well. Al is aluminum, Cl is chlorine. So aluminum plus Cl2 creates aluminum chloride, or it forms aluminum chloride. And again, I can never change these subscripts. So based on charges and stuff, I had to write AlCl3, and chlorine gas always comes in Cl2. So right now I have 1 aluminum on each side. I have 2 chlorines on this side, 3 chlorines on that side. So in order to change it, I'm going to gradually add stuff to it, and eventually I would see, similar to the steps I took over here, I would get 2 aluminums on each side and 6 chlorines on each side. Make sure that you have these examples written down in your notes to refer back to them. And then the next one, pause the video and balance this equation that you see here. So pause the video and then we'll go over the answer. What you should have gotten was a 4 as the coefficient in front of sodium, nothing in front of O2, and then a 2 coefficient in front of 2Na2O. If you have questions, put a star next to this and we'll talk about it in class. A couple helpful tips. When you're balancing chemical equations, keep the polyatomic ions together, which we haven't talked too much about this, so if your teacher has not mentioned this, don't worry about it quite yet. Another helpful tip is save hydrogen, oxygen, and atoms by themselves for the end. This will just help you when you are working through them to save some time. If you ever think that you're getting really lost, sometimes it's best to just start completely over. So you erase all of your coefficients and start over. And just a reminder with a helpful tip as well, never ever change the coefficient, or never ever change the subscripts. We can only change the coefficients. We have a few practice problems. If you need to, you may draw the atoms. So write these atoms down, or write these examples down. And this is an example. The second one, you're going to want to keep your nitrate or your NO3 together. But write these down. Show me your work where I had, in my examples, I wrote each of my elements here and then wrote how many of each I had there. So I had sodium and oxygen present, so I have sodium, oxygen like that. For this, in your examples, you should do the same thing. So I should see H, I should see O, and then how many on each side, and then changing the coefficients. And same with this one. So pause the video, do these examples, and then we have 2 more as well. Try these 2 as well. So this should be NaHCO3 plus Na2CO3 plus CO2 plus H2O. I'm sorry, this should be a yield sign. It should be NaHCO3 yield, so the arrow Na2CO3 CO2 plus H2O. And that should be a yield sign as well. If you have any questions, make sure to ask them next class. Make sure that the picture you submit is legible, clear, and easy to read. Thank you.